Thank you. All right, let's get this done. So, thank you for the awesome introduction that allows me to skip this and go straight into the meat of the problem. Specifically of my problem here, which is how I can compete with them. Look at them, they're smart, they're handsome, they're accomplished. Well, if I can't beat them, at least I thought I can put my Italian hat on and be louder. And this is how this talk came to be. It will be a little bit different for HPG, but also for myself. I have not a single equation in it, which is probably my first time. And here is the plan. I thought it would be useful as someone from the industry coming to an academic venue to talk about our problems. But I also wanted to make it fun, not come to tell you the usual, that transparency is hard and GI is not solved and all those things. Moreover, I've already done that in the past, probably too many times. You realize that you're old when you see that your slides are in 4/3. So instead, let's add a twist. Let's try to predict the future. It sounds fun, and it has much more potential for my embarrassment, hopefully only in retrospective and not like straight today. The talk subtitle, if I had space for one, would be how to navigate the future without hype or hate. And this is how we're going to do it. First, a good theory needs to state its assumptions, and I think even a bad one should. And then from those assumptions, we'll try to derive more or less logical conclusion in the form of bold bets. And let's right into part one, the industry. First of all, the industry, what industry, right? Everything trends towards real-time, and real-time rendering is everywhere. Web, commerce, AR, XR, digital twins, like the industrial application side, real-time CGI and VFX, the stray short there, it's pretty amazing to witness. We live in exciting times. But here, I'll still be talking about video games for a couple of reasons. I think it's still one of the largest consumers of real-time rendering technology. It is an industry currently facing some transitions that are interesting to investigate, and it happens to be what I know best. This first part is effectively an abridged and updated version of a previous talk I gave, the value of pixels. And it starts with my "you won't be Carmack" hypothesis, which goes as this. In the early pioneering days of game dev, technology directly unblocked new possibilities. Carmack takes BSPs and creates not just a game, but one of the biggest genres in the industry even today. Hardware and software innovation pushed the whole industry forward. Then we moved to a stage that I call competition for excellence. So here, better technology became a back-of-the-box feature, being able to render at certain frame rates, resolutions, or in general, certain rendering feats were a competitive advantage for a product. Better technology meant better sell, both on hardware, software, console walls, all that jazz. As time went on, we also saw another kind of expansions, games going beyond the box with the rise of social gaming. In the photos here, I actually chronicled the evolution of social feature as I personally experienced them from a first-person view. So those are a few of the game I was lucky to help on. From my very first shipped title to my current position. And I went basically from single-player box titles to online, DLC, microtransactions, season passes, and now with Roblox, of course, my company is one of UGC content creation. And today, if you observe, I think like all AAA franchises are platforms. Fortnite, Creative, Roblox, of course, UGC stuff, but even in non-UGC games, if you see the launcher of Call of Duty, or if you experience FIFA, and its community around it, like the streamers, everything, game engines are really containers through which we push a ton of content in the service of a community. The box really doesn't exist anymore. It's the continuous content delivery that is what sells a given platform. And let's go to the extrapolation phase, right? Like, what are the consequences of this? So extrapolating, we can imagine that for games as platforms to keep expanding their content reach, they'll want to be able to deliver content everywhere. And actually, this is already happening. I did not know of this Xbox GDC poster I put there in the corner when I started drafting the presentation. But then when I started looking for images, like, this is describing exactly what the point that I wanted to make. So what does this mean for any of us? I think rendering, at least intended in the traditional way of better graphics, is less of a direct driver of dollars. Which is not to say that we solved rendering, or that we don't have lots of improvements to make. I said this a few different times now in various venues, so I'm tempted to call this Angelo's test, which works like this. Look outside the window, look at your monitor. If you can still know which is which, we haven't solved rendering. But the point is that realism now is readily achievable. And you can see here even relatively smaller teams being able to pull off quite amazing results. So what are our next hard problems? I think monsters will lie in the end-to-end content pipeline, from creation to delivery and representation to rendering on whatever screen we are going to target. On the creation front, costs are starting to matter. And the industry knew this was coming for a long while. The graph I copied from Ralph Koster down there is from 2018. But we did not invest much in efficiency, at least from the point of view of technology. And content representation is becoming important as well. Yeah, games are too big. We can't keep asking to download 100 gigabyte patches. If we want gaming everywhere, PC, mobile, TV, fridges, whatever, we have to find ways to deliver or stream content with a bigger degree of flexibility. Game engines today are already often more about what goes on in the cloud than on device. Games needs the cloud, and most AAA games have significant back-end infrastructure investments. And here a quick note about UGC. I was not going to talk about Roblox at all, but I think I can just spare one slide. UGC may seem disconnected from AAA gaming, but I think it's really the culmination of this rise of social trend that we are looking at today. So self-expression is a very human need, not something specific to gaming, of course. And in gaming, this has been manifested since the early days, like if you think about modding or all kinds of experiences that are not designed at all for communication and how people manage to create a community and ways to interact. The real difference between UGC and non-UGC games is whenever this need for creation can be expressed within the game or outside of it. But creativity, one way or the other, finds its way. And of course, in UGC land, with stuff like Roblox, Minecraft, Fortnite Creative, content creation and delivery are directly part of the user-facing products. Right? So those are kind of on the forefront of those problems. And here we reached, I think, a first key point I want to make in the presentation. We do know how to do renderings most of the times, but sometimes we can't afford it to do it as well as we'd like. And with this, I mean that real-time rendering very often is bottlenecked by economics. You can achieve great visual quality if your content is great, even when your math is not the shiniest. But on the vice versa, if you have the best rendering in the world, but the content didn't have the time to mature, you won't get to a final great image on your screen. And I chose here, like, The Last of Us Part 2, which is one of my favorite games. This has what I call almost an unethical amount of sheer content polish, attention to detail that manifests in this amazing presentation. it looks really amazing because of it, but how much human effort did it take to craft? And would that be sustainable for most companies, for most titles to deliver? All right. With that, we get to the more meaty part, which is my bets and also the slightly more rambling part of the presentation. First, let's try to get this out of the way, otherwise like I can just go off stage and close it here. Is human-crafted real-time rendering still relevant? In a way, this is the biggest bet, and certainly the one that is most talked about today. And the pace of machine learning evolution is not a joke. We can't simply dismiss real-time interactive Gen AI because the results today are less than stellar. And it would be really ironic for us to dismiss the effects of the race of computing power. Real-time rendering is the industry where Moore's law has been literally the most visible. If I can be allowed to be an old man for a second, how crazy it is that I actually played both of those games. Like, I remember playing those. In many cases, we are still today putting into action rendering ideas developed in the 60s, now possible due to increase in computing power. So, the AI world model argument, I find it interesting, so we should at least entertain it. It goes like this, to my understanding. If we wanted to simulate ever-increasing details, lighting, physics, object modeling, at a given point we arrive at grain of sands, and we face the reality of a computational irreducible universe. So we need approximations. And what is great at approximating complex functions? ML and DNNs. Now, if you couple this with what is called the bitter lesson, which shortly is the hypothesis according to which trying to mix ML with crafted models is not fruitful, and one should instead double down on computation, bigger models and more data. Well, if you couple those two things together, the need for approximation, and this idea that the best way to do that being a purely learning, purely computational approach, you arrive at what is the possible winning scenario of world models, where having AI going from inputs to final pixel of a simulation engine would be the best strategy. Moreover, we know already that ML wins today sometimes. It can be faster and better than traditional solution for certain problems. I put them fluid dynamics and actor reenactment. So why would a big end-to-end model not be better at everything? Well, I would posit that real-time rendering is a different beast. In real-time rendering, we don't care just to minimize an error metric. We work on the Pareto front of the best possible solution given energy and wall clock time kind of constraints. In other words, real-time rendering is about pixels per watt. Even simply the idea of rendering somewhere and transmitting the results to video may already be too energy inefficient to being a practical, scalable solution for real-time rendering. And we know that generative ML so far is not great at energy efficiency, even for image generation. So today, I don't really see a fundamental reason to bet that ML will be more efficient at modeling phenomena for which we have efficient solutions today. And it may be even true that if we wanted to simulate grain of sands, machine learning would be the best, even for real time. I would say that it's even probable. But we might never need in practice that complexity. The intercept may be impractically far along the problem scale axis. And I think that this also implies that we should really think about the Moore's law and its purposed death, because that could be a risk for the future of ML or real-time ML. And lastly, even if we were to assume that learning always wins, this does not necessarily mean that it can win by restricting itself to neural networks. Now, neural networks are fantastic primitives. They're flexible, they're trainable, and they're incredibly efficient in hardware. They're basically little DSPs that hardware people know and love. But to compete with real-time simulation, we may need to go way beyond pruning and quantization. We may need to learn code or something close to it. And we already saw this in shaders, by the way. Because at the beginning, GPUs were very simple kind of dot product machines. And then we realized that if we could add more degrees of freedom, more expressiveness to them, even if it costs something in the ability to do them very efficiently in hardware, but that extra expressiveness overall couples to give us more efficient solution to problems if we needed to express them only in that very limited framework. All that said, at the same time, I think it's true that real-time solutions to the rendering equations, how we compute light and stuff like that, are bordering insanity. A pixel goes on screen through a complex pipeline with approximations and assumptions all along. If you have seen a production real-time renderer, it's crazy. Analytical light sources, baked radiance, environment lighting, often in different representation for diffuse and specular signals and stuff like that, having then to integrate with materials and the sources of occlusions. Everything has its own approximations, and many signals then get combined together to reconstruct better ones. And there are like chains of fallbacks. Some approximations are baked in tables and polynomials. Some equations are derived with simplifying assumptions. Sometimes we use, let's say, heuristics, where there is bits of code that you look and you don't know where they came from, but they look decent. And at best, all those pieces of the real-time solutions were optimized in isolation, never end-to-end. Often, we also have multiple paths for multi-platform scalability. If you want to try to find the optimal rendering settings on PC for a given machine, it's really like moving a lot of sliders. And today, these things are really so complex that it would take an entire presentation just to go into the details of the state-of-the-art solution for one aspect of the real-time solution. I actually, for a brief moment, wanted to like chart one thing, and then I realized, this will take me way too long to explain, so I cut it down. It's crazy. So I bet there is still lots of potential for improvement there, especially looking at the accumulated error in the chains of approximations we employ. I do think, though, that fixing those issues now has a relatively low return on investment, especially from an art perspective. And art is what motivated this journey to begin with. Right? It's not that we started to do PBR because we want physically accurate things. Like, we are not in the business of predictive rendering. We're not like that kind of engineers. We did it because it was better for the end result from a perceptual and an art production standpoint. So we have lots of pieces, often done with meticulous science, badly glued together, but in the end, the pixels look good. Even when compared to ground truth solutions, we can get quite close. I think like there are remaining wins, but in fixing our maths are more likely to be in the realm of runtime efficiency than perceived quality. And I bet if we wanted to take those improvements and make them, a good idea is start bringing computers into the equation, because this is way too complicated. There is likely an opportunity for significant progress in our soup of math via computer-aided optimization of all kinds, combinatorial exploration, numerical optimization, program optimization of certain parts of shaders, being able to mix handcrafted approximation with learning methods, and moreover, of course, like being able to minimize error perceptually from ground truth is a very useful tool instead of making assumptions or just eyeballing things. And in all of those bag of tools that we should start employing to simplify our life, of course, one avenue are going to be neural networks. Today, we know that machine learning at the end of our pipeline works, like things like temporal anti-aliasing, supersampling, denoise, and so on. And it's obviously should. Those are computer vision problems where AI dominates. Now, the question is it reasonable to think that this role at the end of the pipeline is the only optimal one for AI? And perhaps it is good to remind ourselves of the property a problem needs to have for DNNs to outperform experts. We know that learning-based methods are good if we have a big space where there is a small surface, a manifold of goods where the good solution lie. And this good solution subspace is hard to model by hand. Right? This is critical. So for example, in computer vision, right, the space is gigantic. You have width per height per number of channel dimensional vectors. And most points in this space are random noise. Of course, if I just take one point in this space, it won't be a natural image. Knowing, like expressing by rules, what image look natural and what do not, it's a very complicated task. Like you can just think about something about gradients and edges and textures, you're not going to be very far. So in that realm, learning makes a huge difference. In contrast, if we apply the same kind of rules to the world models I was speaking of before, well, there I think we have problems because it's similar in the sense of we have a huge space, and in that huge space, most of the points are not realistic behaviors that happen in real worlds. Okay, that's true. But it seems to me much harder to try to learn certain things. Like, for example, writing down f equals m times a is much simpler to have something moving than forcing a model to learn Newton's law by watching at videos. Okay, so do we have other good problems of this kind for ML in our rendering pipelines? I think yes. For example, radiance. I believe there is obviously a prior on realistic radiance configuration that could be learned to improve, for example, how we reconstruct radiance from sparse data sources, or how we approximate our rendering integrals and all things like that. Many pieces of rendering pipeline today require heuristics that are beyond what can be efficiently crafted by hand and are much better learned by data. And we haven't explored much to understand what kind of inputs are best fed to machine learning to get the best possible quality per watt. Even just for denoising, which is everywhere, like from shadow maps to AO to the final pixel, screen space reflections, we know that allowing ML to intrude more can yield better results than working on the final human-readable pixel colors. That said, I still don't think that the automation and NNification of the real-time solution of rendering equation will happen fast. That was a mouthful to say. Why is that? Why I don't think that this bet has really big odds? In part, it's because when I look around, I see some reluctance from rendering engineers. Now, I can't pretend to have an objective view of what people are working on, but it seems to me that other innovations saw a more traction, more fast adoption. I'm thinking about stuff like modern GPU APIs, or real-time ray tracing, or SDFs and point-based rendering, right? There are a lot of those things made even for fun by rendering engineers, while it seems that we are a little bit tiptoeing with more carefulness in the machine learning realm. Second, I think that the return on investment, like in dollars, is not high, even with the promise of potentially more runtime efficiency, as it still is something that focuses on the display pixel on screen part of the problem. And lastly, the costs are high, both literally for training and data acquisition, but also in terms of friction. Machine learning is not well integrated in real-time rendering, or at least in the real-time rendering tooling that most video game rendering engineers use. That's why we see, I think, most of the solutions using enhanced from rendering coming from hardware vendors, and why in turn, those by their nature cannot be deeply integrated into bespoke rendering engines. And in that case, it makes much more sense that we see them at the end of the pipeline where you create a library and it's very easy to integrate. Okay, so where could we see more investment instead? And here, I'm going to bet, I'm going to make a bet that goes against some seriously smart people who said the exact opposite recently. Peter, just here last year, and Michael Vance presented with me in 2011 at React, and even then he disagreed with me. Now, of course, they are right. Baking is great, certainly can't be beaten for quality per watt or time, as you're baking computation ahead of time. So by very definition, it's there to provide you with efficiency. The problem that I have with this idea that baking is going to be there forever is that it's very inefficient in all the other content-wise dimensions. It's a lot of data, which means more storage, more bandwidth, typically slower iteration, more investment in the coding and the tooling. It's generally less scalable. So yes, it's the most efficient way of rendering, but if we believe that content is going to dominate, this is also like where potential bottleneck may lie. What I do think it's here to stay is temporal amortization. This is simply too good of an opportunity. We know that frames will always have temporal coherence in an animation. And notoriously now, sometimes we do push screen space amortization too fast. That can happen for a number of reasons. One, I think, could be a misallocation in certain cases of computational resources, like where we spend time calculating effects that end up causing perceptually objectionable artifacts because we have to denoise them, and perhaps those artifacts lower the perceived image quality more than what those computed effects are adding. This does not invalidate the idea, though. Like, finding the optimal balance is part of the artistry of real-time rendering. And for amortization beyond the screen space, we need data structures, and there is a lot of room for improvement here. We still have not found a great way to represent our signals, like radiance and stuff like that, even in static bakes. And in real time, if we wanted to do this as a caching method with incremental updates, things would be much harder. This is another realm where machine learning could help. And we have now in all dimensions more than we can fit. More than we can fit in memory. Well, of course, we do auto-core rendering or hard drives, network streaming. Everything is bigger than we can have in a frame. Engines today are effectively orchestrators of data residency, job scheduling, and computational resource allocation, dynamically adapting frame to frame. Which brings us to the next bet. Rendering will extend to the cloud. Now, video streaming is useful in certain conditions, but as I kind of already mentioned, moving all the compute server side is expensive, and the bandwidth is expensive. So streaming unique per frame, per client data, I don't believe is in general the best avenue. And in AAA today, network-based streaming is already a thing. For texture data, for example, largely driven by the fact that our games are becoming so big that storage space is a constraint. Like, people don't have big enough hard drives. Roblox, of course, is an example where everything's streamed, from the objects to vertices. You join an experience and you don't have anything up front, so it's all network-based. We will need more efficient format for scene representation because of this. Geometry, texture, LOD, compression, procedural generation, of course, which you can see as a form of compression. And once you have that system to stream all the static war data, well, then it's not a stretch to think that you can stream dynamic computation as well. In fact, if you think about it, game servers on the cloud are already streaming dynamic computation in the form of gameplay state. So why not stream stuff that can help rendering? So we should look at the computation that on the server side we can amortize over the world. We have many users in the same simulated world, and world and object space computation obviously can be reused. I'm thinking cloud-assisted rendering in terms of ad hoc or just-in-time computation, things like GI, things like LODs, imposters, visibility, occlusion hints. There are lots of opportunities there. And if we wanted to go far along this reasoning with cloud compute, temporal amortization, new data structures, then should we rethink our rendering pipeline entirely? Taken to the extreme, what really is optimal to compute server side? Can we create some kind of semi-finished rendering in a multi-view scenario? And then what is optimal to deliver? Can we take this semi-finished rendering data and use client GPUs to do the final assembly to the screen pixels? All right, we arrived at my last topic for today. So far, we have talked about rendering, machine learning, a bit about data and streaming. And you probably know what's coming next: generative AI. And I understand this is a controversial topic. I won't talk here about the ethics of Gen AI training and use. You can ask me later. My opinions were too big for the margin of this slide. This is what I wrote down. Here, I want to try to understand it from a technical perspective, from the product opportunity and workflow angles. Progress is happening fast. On quality, I wouldn't bet against the fact that we'll have 3D Gen with perfect topology, rigging, everything that you need. I think it's nearsighted to think that 3D Gen won't be good enough for production. The real question for me is, will it become something like the next photogrammetry? Real-world scanning is ubiquitous now. It worked, it kind of revolutionized game content production, of course, really for realistic games, not just because it's fast and it can produce high-quality outputs, but because it's controllable. It can be art-directed, it can be iterated on many times faster than traditional modeling. Like some of the artists were telling me, it's much easier for me to take an object and slap some plasticine and model it and give it back to scanning than having to go back and forth with traditional modeling. Moreover, it speaks the same language as our established tools and pipelines. In the end, it creates textures and meshes and objects that we can put in our database and mix and match with whatever else we want, right? And I think those are really the characteristics of any good tool. For example, I believe that those are the reasons why AI code assist works so well. Maybe this is already a controversial thing because some people say, no, it doesn't really work for me, but maybe you're being a little bit ungenerous in the expectations. I do think that it works well, especially the code assist in the sense of the IntelliSense kind of replacement, like suggestion search or coding. And I think it works well because it checks all those boxes. So it is fast and it is high quality. At worst, to me, it's like more or less gives the results of conventional intelligence. And at best, I have to take a step back and say, how did you know that I wanted to write that line of code? Like you have to tell me because you're reading my mind. It is controllable, of course, right? Like I'm just typing, I can accept or not accept. It's completely within my normal workflows, it's integrated in the IDs that I use, right? And I also believe that this is why, at least to me, the IntelliSense mode is so much better than the wholesale text prompting, because that doesn't have this characteristic, right? Like, if I generate an entire program and then I keep iterating through text prompts, it takes me a long time to persuade the model to generate what I want, right? Of course, today in the IDs you have both, so really it's up to you. Now, if you look at the same thing, GenAI for 2D and 3D art, on the other hand, the situation is the polar opposite. So we coders are getting it the best. If you have a look, okay, quality, as I mentioned, I don't think it's the real issues. It's already kind of decent, and I believe it will be better, it will be solved. But iteration speed is absolutely terrible. The controllability is terrible. Like, it's not fun to have to know how to express what I want in text prompts that the machine will like. Like, this entire field of prompt engineering is a big warning sign that this is perhaps not the right way of interacting with those models. And in the end, you don't even get discrete, isolated logical objects that I can understand. Like, I can generate something, and then I have to regenerate. Okay, I know that there are models where you can take subsections or whatever, but it's not creating the kind of elements that are compatible with the regular pipelines we all know and love. So this is my bet. For generative AI to really thrive, at least as part of AAA content production, somebody has to figure out what it means to have an AI art assistant or AI art assistants in general. Otherwise, I think this will work, but perhaps not in the context of traditional AAA gaming. They will create in some other genres. Text-based conditioning is not going to cut it. It has to be interactive and real time, and people have to deeply understand artist workflows and needs. All right, and we are reaching the ending. Let's see. So my thesis here is that we defeated the first boss of real-time rendering. We know how to make pretty pictures fast. Pixel quality is so 2010. And yes, real-time rendering is not solved. It's definitely a mess. There are lots of opportunities to do better on all axes. But still, it's good enough quality and it's largely achievable by everyone that it's less of a differentiator. It's not driving sales like it's used to. And more often than not, when we don't reach quality, it's more of a matter of content iteration than it is because of some error in our programming. Our next challenge is then solving the bigger pictures. The bigger picture, delivering quality and quantity everywhere, on every device and on every screen. And it's truly doing all three at the same time that it's hard. Like today you can have quality and ease of production if you don't care about content being widely available. If you're doing something only on very high-end hardware, your problems are lesser. You can have quantity and wide distribution if you don't care about quality, meaning, for example, extremely stylized art styles. Yeah, of course, like then they are something that if you choose your constraints carefully, they can be delivered everywhere. They cannot take a lot of data or computational resources, but then you're abandoning that kind of like realistic quality that we all know and love. And lastly, you can have quality and wide distribution if you are okay going through the immense pain of the state-of-the-art rendering engines and rendering pipeline of today. You know, your several thousand people teams making the gigantic blockbuster games. And now, alas, this is why I titled the talks Hallucinations, of course. I do believe that machine learning is here to play a role, but it can play a bigger one if it works most closely, if it more closely aligns within the industry's incentives and costs and way of working. All right. Questions? Thank you. Oh. Sorry, I almost forgot. Let's do this. Ale. Thank you.
Thank you, Angelo, for this presentation. Any questions in the audience? Raise your hand. Other than that, yo, there we go.
So you said you can't be John Carmack, but if you were 22 now and wanted to do a one-person studio leveraging AI somehow, what would you do?
Sorry, maybe the microphone is off. Can you? I didn't really catch it.
Which button?
No, it's on.
It's on? Is it on?
Yeah,
I just wasn't holding it close enough. Suppose you were 22 years old and want to be the next John Carmack, but with AI instead of BSB trees. What would you do now to do a one-person game company in the next couple of years, so not long-term? Assume the bad tools.
So I don't know. I don't know exactly where you're pointing at, right? Because kind of like not John Carmack. What I mean there is like your code, your rendering prowess changes the entire industry, and I don't know if like I mean. Yeah, it may be true that the AI kind of like opens a new thing there. Maybe that is too much of a bold bet for me to make, but that's a very interesting point, yes.
Great talk.
Thank you.
I've been thinking about this for a while as well, and the bitter lesson says that like general methods will beat expert-made models given enough compute. And I've been wondering, like, we don't have enough compute for everything yet, but what are the areas where you think we do have enough compute and we can build general methods to replace expert-built models, like microfacet models, et cetera, et cetera?
Yes. So then again, I want to be clear here, and also, I will publish those slides. I have like a million more, but I was too stressed that my talk would be too long, so I culled most of them. So perhaps that also will help. But basically, my thesis here is that real-time rendering is not even about, okay, eventually you will have enough compute power. It will always be about what is the most efficient way to do the same thing. And that drive of efficiency is actually what drives most of what I've seen. Like even when I talk, hey, our rendering, math, and pipelines are extremely complicated. A while ago, I was saying, I don't believe, for example, that real-time ray tracing will make real-time rendering easier. And my main reason was real-time rendering engineers will take ray tracing and use it in one more step. It will add. And the reason why it will add and not replace is that if I can solve half of the frame very efficiently, right? And it takes a lot of code, and then only this other part needs ray tracing to go the extra mile, I will always take that. That complexity is the chase of how many months of a programmer you want to spend to get 0.1 milliseconds back in your rendering pipeline. And it has always been, yeah, we will, especially at the top end of the state of the art, we will do whatever. If we have to double the code side to get like 20% improvements in the frame time, we will do it. That is fundamentally where the complexity comes from, right? And couple of that, sorry, this is a long answer, but I also do believe, and this is one of the slides that I didn't put here, of course our computation power is still going to rise, but if you also look at the devices in the hands of people, that's actually not really happening. Right, like the top end, you know, your iPhones and whatnot, they're still growing exponentially. But there are so many more people buying cheaper devices for which the efficiency in watts is paramount. And we are, if you look at the industry, doubling down on the low end, like trying to scale down instead of chasing the high end. You can see how many AAA games now port to PC and try to go more low-end on PC, or how many AAA games want to port on mobile. There is much more compute there that we want to exploit than focusing like we used to do traditionally on the very, very, very top 1%.
Which type of game developer do you expect to benefit more from Gen AI? The small indie developer or the big company with lots of resources to throw at it?
I imagine the small indie dev right now. And the reason why is that, then again, big bets, don't quote me, it will be completely wrong, right? But what I'm seeing is that the companies behind Gen AI, of course, want to target the largest number of users, obviously. And it's so much better to try to make things for an emergent new market than trying to focus on, you know, the 10 gigantic gaming studios with our tendency of, you know, consolidating those in bigger and bigger and bigger gaming studios. So I don't think there is enough market there to be interesting. And I kind of saw it even other times, right? Like when we had YouTube, right, we created a new way of creating movies or video-based content with huge professionality, but that didn't change the way of Hollywood movie making, almost at all. It just created this new, gigantic, and much bigger segment. So right now, I think that is the answer. If someone tries to like solve Gen AI specifically for AAA, as I kind of was hinting, then there is a chance that both will benefit.
So, especially in the context of AAA gaming, it seems tempting for studios to replace professional artists with a Gen AI approach. But if I understand you correctly, that's not what you think is likely to happen. If I understand you correctly, it's more like this IntelliSense type of assistance.
Now you want really to like go into controversial stuff. So, okay, then again, my personal opinions here, right? I believe that is not mainly driven by technology. Like we saw it always. It's not that Gen AI is, okay, now we have Gen AI, the crisis of the industry or anything. Like when we went from keyframed animation to motion capture, when we went from 3D modeling to photogrammetry as I was showing, we had a lot of technologies that draw the artistry in game making to higher and higher level, right? Like, then again, motion capture, now I need an animation director for actors or for athletes less than the most experienced keyframe maker, right? But we didn't lose people in the industry at all. And I think so that the main driver of we need more or fewer people is not so much the technologies, but the economic realities. So of course, if that market is not expanding exponentially as it was before, then you live through tougher times. But okay, I'm not an economist as well. There are people who can speak much more eloquently on this, but this is my opinion.
Any more questions?
As we approach photorealism with generative AI, I think something that's lost is the disparity that we still have from reality. It triggers simulator sickness in people, and I think that people who are growing up today's society who are exposed to Gen AI from a starting point are probably less susceptible to that. I don't know if that's true, but do you have any comments with regards to that? Yeah, it's hard to describe it further than that, but I can go into more detail if you'd like.
Sorry, can you repeat that? I didn't catch it. Also, if you can be a little bit closer.
So, like, if you talk about VR, right, and there's a huge problem in VR because of the disparities from reality. Like, we have the visual acuity, proprioception, and the stimulation, right? And when things are not aligned properly, it causes sickness in us. With Gen AI, like, I can't go online and watch AI videos because they generate similar sickness in me because of the disparity from reality. It's going to be something like the eye movement, for example.
I see.
You know, and that is really like I don't know if like children are going to be is kind of controversial. Children are become desensitized to that if that's the reality. But like for me, a clean path trace render, it just triggers everything in me that's like creates this contentness that I want from video games. Yeah. And I think that does not happen with generated AI content for me individually.
Yeah. No, okay, I get it. So it's a very interesting observation. To be honest, I don't consume enough Gen AI content to like have experienced that. I think if I can be, because I don't have an answer for that. It's too far from my expertise. I think a little bit, the only thing that it's closest to that I was talking about is how sometimes I think we risk, and we always did, to be honest. It's not like a new thing that, oh, now because of denoising and whatever, there are those problems. But it's very tricky to optimize for perception. So sometimes you do and chase things that then have different kind of artifacts, right? That maybe are good in static images or when it's converged or at given power levels, and maybe they weren't the optimal solution, but that has always been a problem, like that kind of thing. And we even saw today and like how have always been very passionate about perception in computer graphics, and it's still very, very far from a solved problem. So I think there is a little bit still to improve about that.
Thanks. That was an amazing talk. One of your big bold bets was much more cloud gaming. And it's actually heartwarming to hear because I think in the last year or two of AI everywhere, everyone's kind of ignored the big change that's happening. Do you think does this mean that every AAA title in the future is for the most part on most consumers' devices going to be streamed from cloud in one way, shape, or form? Or do you think it's still going to be very stratified, where certain titles like the Robloxes of the world are going to be doing more cloud gaming, but you're also going to have a lot of other kind of conventional single-player games or small-scale indie games that are still not cloud?
Yes. So, my opinion, I kind of hinted at it, right? Like, I think that you are more likely to see a lot of more complicated data being streamed from UGC people, just because there is a greater need, right? When I said, of course, when you do UGC stuff, this content representation, delivery, creation experience is really part of your product, of the things that people touch. That is the reason that I think probably you will see there first. For bigger AAA games, see what happened, right? Like, there is a lot of titles are streaming textures because of the concrete need of you don't have hard drive space. if they don't have any other thing, like in the end, you only solve the problem that you strictly need to solve, right? Like, so there are certain things, certain products where those problems are more in your face, and certain where, well, maybe I should prioritize other things.
Do you have a question? Yeah.
Hi, yeah, I think this was a really interesting talk. This might be a bit of a philosophical question, but I was thinking like, one of the concerns with generative AI is the fact that, you know, it's trained on sort of the state of the world, right? So it reproduces biases, it reproduces sort of like the predominant styles, etc. Is there a concern that the integration of generative AI into art pipelines, even if it is done in an ethical way with respect to the artists, is there a concern that that could stifle artistic creativity?
Oh, well, all questions that ask really to stretch me way into the future. Yeah, I would, okay. Because in the spirit of taking wild bets, my wild bet is no. And the reason why my wild bet is no is that I believe even stretching to, you know, very fantasy scenarios and everything, there is sort of a prior or manifold of reality, right? Like even throughout art history, throughout all kinds of styles, and probably that derives from humans, right? Like even, okay, see the evolution of music and what kind of tonalities and compositions with people all over the world arrived at, right? There is clearly something that it's more appealing for humans in general, and there is kind of the hope that you will be able to learn some of that in this gigantic space of random stuff where most of it is complete noise that makes no sense and it would never be pleasing. That said, then again, it's a very, very wild bet. I don't know. Yeah.
All right, I believe we're out of questions. Let's thank Angelo again. Thank you.
Thank you. Oh, and as I mentioned, I will at a given point publish this, and it has a ton more slides because that is a way for me to offload my anxiety. Like I want to say too many things, and that's like, okay, I'll put it in slides. So if you enjoyed this, download the slides when I publish them. Thank you.